This video is about phosphorus and its important components. First, we'll see what are the allotropes of phosphorus. Allotropy is the property by which a single element exists in more than one stable forms. White phosphorus, red phosphorus and black phosphorus are the varieties of phosphorus that we find. So these can be considered as the allotropes of phosphorus. Coming to white phosphorus, it is otherwise referred to as yellow phosphorus. It is the most reactive among the different allotropes. Why it becomes reactive is due to its peculiar structure. We'll come to it later. First, you find that due to the high reactivity of phosphorus, it is always stored under water. It is highly soluble in carbon disulfide but never soluble in water. Due to this reason, it is always stored under water. White phosphorus has a garlic-like smell and is poisonous in nature. When we check the structure, it is made up of independent tetrahedron structures. These structures are otherwise referred to as discrete P4 tetrahedron. White phosphorus also shows the property of chemiluminescence. Now, what is this chemiluminescence? It is the property by which the substance absorbs some radiation and emit it in dark. As a result, you find white phosphorus starts glowing in dark, and that is referred to as chemiluminescence. On checking the structure of white phosphorus, you find that the molecule is highly strained because of an angle strain of 60 degrees between the neighborhood pp bonds. How can we prepare this white phosphorus? In the laboratory, it is prepared by treating calcium phosphate with silica and carbon in an electric furnace. When calcium silicate, carbon monoxide and white phosphorus are obtained. Coming to the different reactions of white phosphorus, the most important one is the reaction with boiling sodium hydroxide solution. White phosphorus, when it reacts with hot boiling alkali, it produces phosphine gas along with sodium hypophosphite. Next variety that we have is red phosphorus. Red phosphorus is somewhat stabler than white phosphorus. It's an odorless, non-toxic solid formed from white phosphorus, and it does not show chemiluminescence. On checking the structure, we find that it consists of linear polymeric chains of tetrahedra joined together by pp single bonds. Have a closer look at the structure of red phosphorus. White phosphorus, the strained molecules, when they are heated, it relieves its strain because of the breakage of pp bonds, and the individual tetrahedron structures get joined by new p single bond p. So the molecule will be relieved from the angle strain and the red phosphorus is somewhat stable. Coming to the preparation of red phosphorus. Red phosphorus is prepared by heating white phosphorus at a temperature around 573 Kelvin in an inert atmosphere. You know that white phosphorus is a substance which catches fire easily due to the low ignition temperature. You find for white phosphorus, the ignition temperature is close to the room temperature. It is around 303 Kelvin. So it's difficult to keep white phosphorus at 573 Kelvin, for which we have to apply high pressure. So under high pressure, white phosphorus is converted to red phosphorus, and this happens in an inert atmosphere. Coming to the next variety called black phosphorus. Black phosphorus comes in two different varieties. One is called the alpha black and the other one is beta black. Alpha variety is prepared by heating red phosphorus in a sealed tube at around 803 Kelvin. Whereas the beta variety is obtained from white phosphorus, and that is prepared under pressure at 473 Kelvin. Coming to the different molecules of phosphorus, the first and the most important molecule is phosphine with the formula PH3. It is having a structure similar to that of ammonia, that is, it is having trigonal pyramidal structure. Phosphine is a colorless gas with a rotten fish smell. It is highly poisonous in nature. Phosphine gas catches fire abruptly only when it is impure. Under the pure condition, you find that it is a non-inflammable gas. It catches fire rapidly in the presence of white phosphorus or P2H4. Coming to the properties of phosphine. When we check phosphine, you find that it can be considered as a Lewis base and it dissolves in water, forming alkaline solution. When phosphine is kept in contact with oxidizing agents like nitric acid, you find that it starts exploding. This is true for both chlorine as well as bromine liquid. Phosphine shows no hydrogen bonding on account of the large size of phosphorus. It is less electronegative in nature. So phosphine never shows hydrogen bonding. Coming to the preparation of phosphine. Phosphine can be prepared from calcium phosphide by two methods. First method is calcium phosphide is subjected to hydrolysis when it produces calcium hydroxide and phosphine. Another way of preparing phosphine is starting from calcium phosphide and treating it with hydrogen chloride. It produces calcium chloride and phosphine. Coming to the laboratory preparation of phosphine, we find phosphine can be prepared by heating white phosphorus with hot boiling sodium hydroxide solution in an inert atmosphere. When phosphine along with sodium hypophosphite are produced. The reactions of phosphine. We have mentioned that phosphine is a Lewis base. So it reacts with copper sulfate or mercuric chloride. When it reacts with copper sulfate, it forms the corresponding salt, that is copper phosphide with the formula Cu3P2 along with sulfuric acid. On the other hand, when it is treated with mercuric chloride, it forms mercuric phosphide with the formula Hg3P2 along with hydrogen chloride. Phosphine, since it is alkaline, it is found to react with HBr and it forms phosphonium bromide. Now we shall see the important property of phosphine before moving on to phosphorus trichloride. Phosphine is very important in preparing what is called home signal. In case of Shipwreck. How the ship gives signal to the neighboring ship. It is by throwing cans of calcium carbide and calcium phosphide into water. These cans are pierced and thrown into water when it reacts and produces ethane gas. The formation of ethane gas from calcium carbide and water is highly exothermic, and that heat is enough to burn the ethane. So in the presence of ethane, you find that phosphine is produced due to the reaction between calcium phosphide and water will also catch fire. With the result, the neighboring ships get the intimation that the ship is in danger and they will come for rescue. This is how it works. Coming to the next one, that is phosphorus trichloride. It has a structure similar to that of ammonia. Here also, on the apex of the pyramidal shape, we have a lone pair. It is prepared by passing dry chlorine gas over white phosphorus. It can also be prepared from white phosphorus using another method by treating it with a chlorinating agent like thionyl chloride. Thionyl chloride has the formula SOCl2. When white phosphorus reacts with SOCl2, it forms PCl3, sulfur dioxide and sulfur monochloride. What is the importance of phosphorus trichloride? It is a very good chlorinating agent and it can be used as a chlorinating agent in organic chemistry. What happens when phosphorus trichloride undergoes hydrolysis? You find it will form orthophosphorus acid with the formula H3PO3 along with hydrochloric acid. Coming to the reactions of phosphorus trichloride. When ethanol is treated with phosphorus trichloride, it forms chloroethane along with orthophosphorus acid. When acetic acid is taken, that is ethanoic acid is treated with phosphorus trichloride, it forms acid chloride along with orthophosphorus acid. So from these reactions you can understand that PCl3 is an important chlorinating agent. Coming to the next molecule, which is known as phosphorus pentachloride. When white phosphorus is treated with excess of chlorine gas, it forms phosphorus pentachloride. It can also be prepared by treating white phosphorus with excess of sulfuryl chloride. What is the sulfuryl chloride? It has the formula SO2Cl2. It forms phosphorus pentachloride along with sulfur dioxide. Coming to the reactions of phosphorus pentachloride, similar to PCl3, the reactions are one and the same, only the side products will differ. First case, when phosphorus pentachloride is treated with one molecule of water, it forms POCl3 along with HCl. This POCl3 formed further reacts with more amount of water forming H3PO4, that is orthophosphoric acid along with HCl. PCl5, due to its peculiar structure, when heated it will form PCl3, which is rather stable along with chlorine. PCl5 is also a powerful chlorinating agent. So when it is reacting with ethanol, it forms chloroethane along with POCl3 and HCl. Acetic acid, on the other hand, reacts with PCl5, forming acid chloride, CH3COCl, along with POCl3 and HCl. Now we shall see the important oxoacids of phosphorus. We have a variety of oxoacids for phosphorus. One set belongs to phosphorus acid. It includes hypophosphorus acid with the formula H3PO2, orthophosphorus acid with the formula H3PO3, and pyrophosphorus acid with the formula H2P2O5. The next set of phosphorus oxoacids are orthophosphoric acid with the formula H3PO4, pyrophosphoric acid with the formula H4P2O7, hydrophosphoric acid with the formula H4P2O6, and the cyclic structure, which is cyclometaphosphoric acid with the formula HPO3 thrice. And finally, the polymeric structure of orthoacid of phosphorus, that is polymetaphosphoric acid with the formula HPO3 n times. The detailed video on the structures of oxoacids of phosphorus will be following. Thank you.